Normally pH scale goes from 0 to 14. It's a 0 in the extreme left hand side and extreme right hand side it's the 14. And middle point is the value of 7. 7 is the neutral. That is the value of pH of water. Why the 7 is neutral? Why the 7 is neutral? Okay. Neutral concentration or neutral solution mainly depends on the equal acidity and equal basic character. Equal acidity and equal basic character. Equal acid and equal basic characters. Okay. From a water molecule, this is the water H2O. This is the water. From a water molecule, we can get OH minus ion and H plus ion. Here, here, square bracket, here the square bracket, here the square bracket designated for the concentration of hydrogen. Okay, okay. From a water molecules, we can get OH, that is hydroxyl negative ions and hydrogen positive ion. And in a water solution, in a water base, the amount of OH minus ion and amount of H plus ion are equals. Okay, that's why it's a neutral, not extreme acid, not the basic. So value of the water is neutral, that is the 7. Okay, then actually in neutral condition, the hydrogen ion, that is H plus ion, and hydroxyl ion, that is OH minus ion concentration are equals. Okay, therefore pH of the fresh water, pH value of fresh water, rather distilled water, the pH value is 7. Okay, anything below the 7, okay, it's a 6, 5, 4, 3, 2, 1. Anything below the 7, the pH value is the acidity is increased in this direction. Okay, and the pH level above 7 is basic. Okay, so the scale of the pH scale that range from 0 to 40, it's a unidirectional. It starts from the neutral condition 5. It moves right hand side with an arrow in right hand side. The alkalinity or the basicity increase towards the right hand side from neutral point, and from the neutral point to the left hand side increase the amount of acidity. Okay, this is the basic principle of the pH scale. 7 is neutral, it's the pH value of a water or a fresh water or a distilled water or the water of 25 degrees centigrade temperature, because here's the equal amount of H plus ion and OH minus ion. That's why pH of water is neutral. If you move from the right hand side from the 7, the alkalinity increase towards the up to 14. And if someone moves from the 7 to left hand side, 6, 5, 4, so on, then it increase the acidity. This is the basic principle of soil pH scale. Now one question is that why pH scale range from 0 to 14? For the water based solution, or the soil character is very closely attached with the water character. For the water based solution or water based soil is related to the water, so the scale varies from 0 to 14. Why 0 to 14? Okay, why 0 to 14? So water molecules, that is H2O, here the with bracket system we can OH minus ion and H plus ion, both are 10 to the power minus 7 and 10 to the power minus 7. So H2O is 10 to the power minus 14. That's why the pH scale in water-based solution range from 0 to 14. Okay, 0 to 14. Okay, and it's normally defined by the KWE equals to H positive ion and hydroxyl negative ion is equal to 10 to the power minus 14. That's why pH scale normal range is from 0 to 14. 0 to 14. Okay. Now come to the point of why what is the formula used in the calculation of pH. Okay. Now come to the point of formula. And normally pH concentration or the pH value of the soil or any solution normally calculated with the help of a formula, that is pH is equal to minus log plus hydrogen ion concentration. This is the formula for the calculation of the pH values. Okay. Now the question is why for the calculation of pH or the identification of acidity and alkalinity, why we will select the hydrogen ion, why we are thinking about the hydrogen ion. Okay. Before going in this part in details, okay, one thing is very important. If you move right hand side from the 7, then and then the rate of alkalinity increase from if you move from 7 to 6, then the rate of acidity will increase 10 times. If someone moves from acidity pH value 6 to 5, then the acidity will increase 10 times. If as value of acidity value of pH 7 to 6, and then it will increase 10 times, 6 to 5, then it will again increase 10 times. Rather from 7 to 5, it will increase 100 times, and then 7 to 4, 10, 10 and 10, it will increase 1000 times. Okay. Then extreme acidic condition will found in 0. Okay. Then there is an inverse relationship between the value of pH scale and the concentration of acidity, rather concentration of the hydrogen ion. When you are moving from the left hand side from the 7, then the value of pH is gradually decreasing, but the value of acidity, the concentration of acidity, concentration of pH ion will increase. There is an inverse relationship, okay, in between the number or value of pH scale and the acidity. And if you move from right hand side from the neutral point, that is the 7, and then from 7 to 8, the rate of alkalinity will increase 10 times. 8 to 9, it will increase 10 times, so on. It's just like a Richter scale or the Richter scale or the decibel scale. Okay, it is an exponential scale. This is the basic theme about the soil pH scale. Okay, and it will start from here. It's moved right hand side with an arrow and left hand side is in an arrow. Acidity increase, alkalinity increase in right hand side and acidity increase in the left hand side. Okay. Now come to the point of formula. Okay. Formula. Suppose we are all familiar with the oxygen, molecules of water. It's normally H2O, and there is another molecule of water, H2O, and H2O is, we can write in that way, H2 and O, H2, 2H and O. Okay, there is an interaction. Okay, there is an interaction. One hydrogen ion from the oxygen molecules come here, released from one hydrogen ion is released from oxygen atoms, or water molecules, and it's added in here. And what will be the result? And that will be OH. Okay. Okay. That is a all. There are two molecules of water, one molecules and two molecules. Okay. And that is H2O, and this is also the molecules of H2O. That is 2H and O. This is 2H and O. One H molecules, 1H atoms released from oxygen, released from the water and added here. What will be the results? There will be 3HO with the 3H, and there instead will be OH. Okay, that is hydroxyl ion, oxygen, and OH is known as hydronium ion. Hydronium ion. This is the basic theme, basic chemistry behind the acidity and alkalinity of soil. OH negative ion responsible for the soil basicness or alkalinity, that is the OH ion, and OH negative ion, and AH3 ion, that is the hydronium ion, is responsible for the soil acidity. Okay, so come to the scale of pH. Okay, OH ion concentration increased in right hand side and AH3 ion concentration in the left hand side. OH minus ion responsible for the soil alkalinity or basicity, and AH3 ion or more hydrogen ion concentration responsible for the soil acidity. This is the basic theme of soil acidity and alkalinity. Now come to the formula. This is the formula for the calculation of soil pH. Okay, go for the calculation of soil pH. The pH formula is pH is the minus log, that is negative logarithm bracket positive hydrogen ion. Okay, positive hydrogen ion. Normally here the bracket, square bracket designated for the concentration of hydrogen. Okay, why the hydrogen? If this is the question, why we are taking hydrogen? Okay, why we are taking hydrogen? This is the basic question. Hydrogen molecules. Okay, density of hydrogen molecule, density of hydrogen molecule ranges from 0.00000001 to 1. Okay, if because of we take example of water to find out the soil pH, we can take example of water and we can find out the soil pH or the pH of the water. Okay, and suppose, so we are taking, or scientists are taking, Danish scientists to propose the formula of soil pH or the water pH or the pH proposed. He calculated, he took the hydrogen density or the density of hydrogen moles, that is the moles per liter. Okay, density normally identify the moles per liter, Okay, so this is the formula, Okay, now pH of the fresh water. The hydrogen ion concentration of a fresh water is 0.00000001. This is the known attributes. Okay, hydrogen ion concentration of fresh water or the water with the room temperature or the water with the 25 degree centigrade temperature is 0.00000001. So also go for the calculation. Take a scientific calculator. And scientific calculator, press log, because there is a log, press log and identify this negative logarithm, this value log, and press the number, press the molar density of the hydrogen molar per liter, moles per liter, 0.123123 and then equals to, this is the -7. Okay, so write the -7. Okay, that is the -7. A pH value always based on log 10. Okay, so this is 10 to the power -7. This is log 10. Sorry. This is log 10. 10 to the power -7. Both are minus. Then pH value will be 7. Okay, so pH value of the fresh water or the distilled water is 7. This is the basic principle to identify the soil pH. Okay, you identify the hydrogen ion concentration in any solution and find out and convert it into the log, and you can get the value of pH.